Yeah. So this is our solution. We prepare copper to sulfate solution. So in that solution, the metal that we have is actually copper, right?
Yes.
That's the metal we have in our solution. Now, what are we doing to that solution? We are actually adding iron to the solution. Now, in this solution of ours, where I've got copper 2 sulfate in here, and then we dip in NaO. You know, NaO is made up of iron, right?
Yes, it's
Dip
made out of
in,
iron.
yeah, we dip in an iron in that solution. So what we expect is that we are going to compare these two metals, copper, and iron. Which one
Yes.
is more reactive than the other? The information that I have is that iron is more reactive. Now I'll come and show you how you are going to confirm. Iron is more reactive than copper. As a result, this iron here now is coming to take up the place where copper is. And when that
Okay.
happens, the copper is formed alone as a product. While in the place where copper was, what we're gonna have is what? Iron. Is it okay?
It is okay.
Yeah. Now, when that happens, what should come to your mind is that this one which has been removed from the compound is what? Less reactive. That's what this point is actually talking about. So iron will displace copper from its copper sulfate because the iron is actually more reactive than
Copper.
copper. Now, there are a few observations that you must make, and they like asking this question. What are the observations that you are likely to make? So the truth of the matter is that copper 2 ions are colored, and the color is blue.
Blue.
So this solution of copper 2 sulfate, we expect it to be blue. We expect it to be blue. And then when this reaction actually happens, have you seen that now at the end of the day, we're going to have iron sulfate?
Yes.
So the iron 2 in solutions, the color is actually
Green.
green. Yeah. So the observations that you should make during this reaction is that there will be a color change from blue to what?
Green.
Green. That is the first observation that you are likely to make.
Okay.
The second observation that you're gonna make is that iron will what? Will dissolve. Have you seen that from the reaction that we have? Iron here is a solid. Have you seen it?
Yes.
And have you seen that now iron is in the aqueous form,
Yes.
meaning it has dissolved? Remember, aqueous is a form in which a metal is or a solid is when it dissolves. So for it to have transitioned from solid to aqueous, it means the metal has actually dissolved. Yeah,
Okay.
yeah, yeah. So that is the first reaction that we can make. The second and the last one, forget about this, the explanation just the same. So the observations that you should focus on, one, the color of the ions. If possible, you also pay attention to the state symbols. So
Okay.
the second one, when you have copper and silver, the truth of the matter is that copper is more reactive than silver. So can you tell me what you are likely to experience?
But then,
Um, when this reaction is initiated, where copper is to react with silver nitrate, and we know that copper is more reactive than silver. What do you think is likely to happen?
The the copper will dissolve.
Okay, the copper will dissolve, and then
The silver will remain on its own as in solid form.
the silver now will form as deposits inside of a solution, but to actually be in solid form, right?
Yes.
Exactly. What else do you expect? Do you expect any color change?
No, I don't think so.
I see. Let's look at these metals that we have. At the beginning, silver nitrate is colorless. Now, have you seen that here we are going to have copper 2 ions in solution?
Yes,
What color do you expect it to have?
the blue color.
Exactly. So each time we have copper ions in solution, copper 2 ions in solution, we expect a resulting solution to have the color of blue.
Okay.
Yeah, yeah. Now, I have to tell you this, Miambo. There are some students who are taught by teachers, the same teachers, even from the school, that sometimes they start promoting them to give them good marks, even when they have not passed. For me, I want you to learn that that will never happen. I want you to stand on your own, even if we are doing these discussions. I will not favor you in school. I will not favor you in class. Okay?
All right.
I
Yes.
want you to, I want you, not that I don't want to be there for you, but I want you to know that learning to stand on your own sometimes is better than someone who's protected.
That's true.
Yeah, okay. So any question on the displacement?
So far, I'm okay.
Good, good. So that is what we are saying. So the other observations that you can make, other than the color change, the dissolving of a metal, sometimes even the gases actually form.
Okay.
In a moment,
So,
in a moment, it is
as long
an
as,
sorry.
as long as a solution has, I think, as long as in a solution there's copper 2 ion, there's always a color change,
It will
the
always
color of
be, it will always be blue.
okay.
For as long as there's iron 2, the color will always be green.
Okay.
For as long as there is iron 3, the color will be like that of rusted iron, brown.
Oh, all right.
Okay. Have you taken note of this?
Yes, I have.
Okay. Now, in a moment, in a moment, in a moment. Okay, now let's look at an exercise. Just like a quick one. What did you
Sure.
what would you see when zinc? What would you see when zinc is added to copper 2 sulfate solution? So what we're actually talking about is Zn, which is a solid. Now, when this solid is added to copper 2 sulfate solution, what are the observations that you are likely to see?
First of all, blue color.
What about the blue color?
Since the solution contains water
Are you
with
using
phosphate.
headsets?
Yes, I am.
Okay, it's not quite clear. Um, Remember, when you're giving
Yes.
when you're giving the description of the observation, talk about what you see before and what you'll see after.
Okay.
Like the way we're saying the color will change from blue to green, it means from the beginning of the reaction, initially the color was blue. After reacting, then the color changes to green, right?
Yes.
Now, what would you say about this solution? Before, remember the color is coming from this one, which is in the solution. So what color does it have?
It's the blue color.
Okay. So you expect the blue color from the beginning. And then at the end of the reaction, what do you expect? First of all, what are we forming?
They are forming zinc sulfate and, and copper.
Exactly. So we'll have zinc sulfate. And now this is the one which is in solution. This
Okay.
is the one which is in solution. Plus C, copper. And therefore, which of these two, between copper as a product, between copper and zinc sulfate, which one will give us the color?
Copper.
No. Copper is now formed as deposits at the solution, at the bottom of the solution. The one that is giving us the color is the solution.
What is zinc sulfate?
Exactly. Are you getting that?
Yes, I am.
Mhm. So which color do you expect?
More choice. So what is zinc? Green.
One.
I'm saying I don't know the color of zinc. I know it's green.
So zinc gives a colorless solution.
Zinc is colorless.
Yes.
Oh, okay.
Yeah.
Let
So
me put it down.
we expect the color change from blue to colorless. I hope you get it.
Yes, I do.
Good. Now, these metals that we're talking about, first of all, there are examples of non-renewable assets. Metals are natural or national assets, yeah? But
Mm-hmm.
these national assets, some of them um, some of them are renewable and others are non-renewable. So what type of assets do you think metals are? Are they renewable or non-renewable?
Metals, they're non-renewable.
They are non-renewable, exactly. So because they are non-renewable, when they are when we have something we are working on, we should be mindful that one day they will finish. And when they finish, as a country, we'll be operating on loss. Therefore,
Yes.
therefore, it is very important to understand that there are ways in which we can preserve the little ones that we have.
Okay.
And one of the way is by making sure that, like what happens to a car when a car is damaged, they don't get the entire car and go and throw it. And not because it has gone off. No, it is either we repair it. If we can't repair it, where do we take the rest of the spare parts? Maybe for scrap metals, right?
Yes.
Exactly. So that itself as a process is an example of metal recycling. So,
Okay.
yeah. So that's why I'm saying here that metals are finite resources. Once they are done, we are doomed. Therefore, the best that we would do is to recycle them. Now, why do you think recycling of plastics, why do you think recycling of metals is very important? What are the advantages?
Mm-hmm. It can be used to create different other things.
Okay? Now, remember the time you are making other things, you instead of now here's the thing. When making other things, let's say you have a car body, you
Yeah.
recycle, we recycle that car body, we make, let me say, metals for constructing the bridge.
Mm-hmm.
If you did not recycle that car, which is damaged, the metals for constructing the bridge, we could have gotten them from the mines, right?
Yes.
Now, because we have used something which is spoiled to make the bridge, meaning we
Yeah.
have reserved the natural resources.
Yes.
So, one of the advantages is that it is a better conservation of natural resources. So, instead of mining new metals from the ground, we better use the ones that are already mined. That way, in the finished product, that is not working. So, by so doing, we have actually preserved our natural resources.
Okay.
Yeah, that's one. Even as we are doing that, we should be reminded that meaning mining activities are lessened.
Hmm.
And what do we know about
Definitely.
mining activities? You are from the copper belt, I believe. The noise
Yes.
just from the mines,
Yeah.
the smoke from the mines. So we are rest assured that when less mining activities take place, we will have less air pollution. We will have actually less even land pollution because some of the Kitwe, the
Mhm.
what do you call the Black Mountain, right?
Yes.
So that land where the Black Mountain is actually sitting on, there will never be any economic activities. No one will go and build a house there. Why? Because there are heaps of sand. Meaning,
Mhm.
if we do more of such mining activities, we will have a lot of land that will be taken up by the soil. So if we do less of mining activities, we'll preserve our land, we'll have less air pollution, even the noise pollution will actually not be there. Not too long ago, we heard of a report where a certain mining activity polluted, is it Kafue River?
Yes.
So in a moment, less activities are taking place. We are rest assured that such activities will not be on the rise. So actually, recycling of metals plays a very vital role in our ecosystem. Yeah.
Yeah.
The other thing is the metals that are from the finished product, let's say a house, the iron sheets are washed away maybe by the wind. If we don't get those iron sheets, recycle them and put them into good use, definitely we need to look for a place where we are going to put them, right?
Yes.
Yeah. So meaning it goes back to landfill, like we talked about. A lot of spaces will be just look at the garage that has got a lot of dead cars.
Yeah.
There's no parking space. So if those cars cannot be fixed, why can't we remove them? Let's go and melt them so that we do a recycling of metals. At the end of the day, we'll have something better. Yeah.
Yes.
So metal recycling, even plastic recycling is very important in many ways.
Mm-hmm.
Okay. Now you are the one who's talking. Can you ask questions?
So the way you said, with recycling, less mining will take place,
Mhm.
which we do that. No, the mining hasn't taken place, that's why the increases. Oh,
Your voice through the headset is not quite constructive, so I'm having challenges hearing it.
I'm saying that point number two
Mhm.
states that with recycling, less
Mhm.
mining will take place.
Mhm.
In this case, I'm saying here in Zambia, this hasn't actually been proven because even after recycling, we don't have those recycling facilities ready as for one. And two, even though if you are there, people will stop mining.
Um, that's why we use the word less and not
That's why you,
yeah, and not a complete elimination of the mining processes. No, we have used the word less.
okay,
Why? Because you are from a modern life. If you were
Yes.
in my old age, I would use a very good example that you'll understand. Back then, we never used to throw
Mhm.
leftover nshima. When it
Okay.
remains, we'd save it. The following day, we'd warm it and then eat it. But you realize that when that nshima is saved, is kept overnight in the pot where the pot or the plate, whatever vessel where that nshima is kept, when you are removing it, you will have some part of nshima remaining in the walls of the vessel, right?
Congo.
What?
So in the day that Congo or something like that. It's
Exactly.
had
And when that kwangwa is, remember that kwangwa will not be eaten. So the truth of the matter is that the nshima that was served for eating, now when you reheat it and you do all those things, the quantity of nshima that you will eat is less than what was served. So the truth of the matter here is that if you are recycling, let's say, for 500 kilogram of iron, during the recycling, you
mm-hmm.
expect to obtain less than that, right? Because part of the
Yes.
4,000 kilogram of iron which is being recycled, part of it might be lost. So if we say that mining stops taking place, then we might actually end up having less products than what we're supposed to have because of the loss of mass of these metals during recycling.
Okay.
Yeah, yeah. Any other
Can
question?
I ask another question?
Sure.
How do you identify the colors of these metals? Like they said zinc is colorless, copper two is blue.
Oh, machine. So when we start looking at, you've done acid bases and salts, right?
Yes.
There's a practical we are actually doing next week. So I'll come to your class and then I'll
Okay.
take you through common methods that you were supposed to have, how to identify these
Okay.
methods. But there is no proper or
All
logical
right.
explanation that one would use to explain where the blue color is coming from, especially under your syllabus. That point might not be there. But here are the common metals with their expected colors.
All right.
Metals with expected colors. So metal number one is iron, iron 2. In iron form, this metal is what? Green. Iron 3, this one is reddish brown. 4 or 3, copper 2, ions, this one is light blue. Cobalt chloride, cobalt ions is likely to be pink. So these are the only ones that you will be asked in an exam. Okay?
Okay.
You need to understand, you need to know them.
All right.
Mhm. Yeah. Anything else?
I know.
Very good. So we can now go to the last part of the thing here, which sometimes disadvantages. So one of the disadvantages is that for mining activity is better because you are specific of where you are going to find the minerals, right? Minerals
Yes.
are only found within the mining company, within the mining firm. But if you're talking about the recycling of metals or recycling of plastics, you see what happens to these boys that go around picking litters, right? So
Yes.
there's no specific place where you are rest assured that when I go there, I will find the metals, the scrap metals to be recycled. No. So people move around looking for plastics, move around looking for metals, mabattery osila ya kumotoka atigula. I'm sure you've heard of such phenomena, right? You've never
Yes.
heard of mabattery osila ya kumotoka atigula?
I've heard so.
You have, yeah, exactly. So there is a lot of transportation cost, a lot of transportation cost because of the recycling process. A lot of um, transportation costs. That's number one. Number two, even after you've collected the mabattery yosila yakumoto katigula, at the end of the day, you need to start sorting them, right? No, these batteries were my 12 volts, they were my 150 amperage hour. These ones were my N70. So even after
Yes.
you bought those batteries, you need to start sorting them. No, this battery was the lithium battery. No, this one was gel. This one was acid battery. This was a solar battery, car battery. So at the end of the day, you still have to do the sorting. All that is a sheer wasting of time. But if you had only a single metal being mined from this particular mine, you don't need to sort them out because you know that it's on iron that are contained in there. But if you look at a battery, it contains aluminium, it contains acids, it contains the plastic cover, the terminals. So all those processes of sorting out is quite tedious. Yeah. So those are some of the things that you can talk about as the disadvantage of metal recycling.
Okay.
So can you mention them? One,
What?
disadvantages of recycling of
So,
metals? Yes.
the disadvantages of recycling methods,
Mhm.
time consuming,
Yeah, it's time consuming. What else?
mm, so,
What else?
um, hmm, so the facilities are not present. It's going to be hard for it to recycle.
What?
If there are no proper facilities for recycling metals, you'll be unable to recycle that same metal.
Yeah,
So proper facilities, what I can say.
it needs proper facilities, proper facilities. It 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 require it requires um or it involves a cost in terms of it is costly in terms of transporting them. Remember, there are three processes involved. One, there's collection from the from place to place where these metals are, you collect them, you take them to one point where you are keeping them, and when they are enough, then you transport them into the area where they are going to be recycled. So it's a little bit cost in terms of transport. And then, yeah, those are some of the things that you can talk about.
Yes, sir.
Therefore, if we can't recycle them, let's say all the metals that are on the surface are done, but we need
Yes.
manufacturing processes to continue. What are you supposed to do? We'll go back to mining, right?
Yes.
Yeah. And when we mine these metals, we don't mine them as pure, unfinished products. No. Remember, these metals are on the earth, in the deepest of the soil. We have to dig, we have to get them, we have to purify them. Therefore, the method within which these metals are separated from their impurities is what is called extraction of metals.
Metals.
The first session is done. Are you up even for the second one?
Yes.
Okay. So when we come next, we're going to look at extraction of metals.
Right.
Thanks a lot.